Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Today we will talk about social vulnerability in modifiable area unit problem perspective. In this topic, there are several contents. The first is about introduction. Second, about social vulnerability. What is the definition of social vulnerability? What is indicator of social vulnerability? And how we can survey of indicator of social vulnerability. Third is about spatial unit. What is the concept of spatial unit and what is the hierarchy of spatial units? Fourth is about modifiable area unit problem. What is the concept of MAUP? Solution to identify MAUP and what is the concept of spatial autocorrelation? In this topic, we will give some example case study. The first is from Jelinski in 1996, second from Nelson and Brewer in 2017. And the last, the conclusion of this topic and some reference for this topic. Okay, we go on to the introduction. Have you ever seen a disaster risk map like this? What do you think about this map? For example, for this area in red circle, what do you think? From this map, there are two problems in here. The first is about disaster risks. Disaster risks can be obtained from hazard, exposure, and also from vulnerability. There are four kinds of vulnerability. The first is social, economic, ecology, and physically. But in this topic, we will explain about social vulnerability. The second problem is about data from this map. The data presented in this map has been generalized and aggregated and scaled so as if the data distribution was cluster, the ASEAN and Africa region tend to be at risk of disaster, while Europe and America tend to be at lower risk disaster. So, what is the purpose of this article? What is the social vulnerability as a part of disaster risks? And what is the problem if the data has been generalized, aggregated, and scaled? So what is the solution for this problem? And the last, what is the example for this problem? Okay, let's go talk about social vulnerability. What is social vulnerability? Based on some study-related social vulnerability, we can conclude that social vulnerability is the lack of the ability or the capability or the sensitivity of person or community to face or to respond or to recovery from any dangers like volcanic eruption, landslide, flooding, fire, and others. Based on this, their character like sex, age, education, and also employment. And this characteristic will be the material of indicator of social vulnerability. Okay, let's go to the next part, that is the indicator of social vulnerability. Based on some study related social vulnerability, there are some indicators of social vulnerability. They are sex, age, education, employment, income, household, residential, and also mobility. This indicator also have some sub-indicator. For example, indicator of age have some sub-indicator like rate of children under 40 years and rate of people above 65 years old. And this indicator will be calculated to be an index of social vulnerability. And this index that influence the disaster risk. But at this time, we will not explain about how to calculate the social vulnerability index. Maybe we can explore more about that in the next time. Okay, next, we will talk about how we can get the data of social vulnerability. This is just a simulation for example. Okay, for example, this is a community of people, and then the census officer will come to them and he or she will record all of socioeconomic data and also include of that indicator of social vulnerability. After that, the data will be stored based on administrative unit like this. Nelson and Brewer in 2017 also mentioned that socioeconomic and health analysts commonly rely on areally aggregated data, in part because government regulation on confidentiality prohibit data release at the individual level. And then, what is the administrative unit? We will explore more about that in spatial unit. Administrative unit like this and pixel unit that we can get from photo image or satellite image are a part of the spatial unit. But in 2015 mentioned that spatial units are the basic building block for the analysis of location-specific attributes. And also spatial units can be formed based on hierarchy. And what is the hierarchy of spatial unit? Administrative units have some level of hierarchy. The top level is country, and the next province, next city or county, district, and the last is village. Maybe in some country have different level of hierarchy. And then pixel unit that we can get data from photo imagery and satellite imagery also have some level of hierarchy. The hierarchy can be built based on pixel resolution or based on number of pixels per zone. For example, 1 multiple 1, 3 multiple 3, 5 multiple 5 pixels. Like this, 100 meters multiple 100 meter resolution 30 meter, multiple 30 meter resolution, 10 meter, multiple 10 meter, 2.4 meter, multiple 2.4 meter, and also 0.6 meter, multiple 0.6 meter. Okay, let's go on to the next part. So what is the modifiable areal unit problem, or we can mention that MAUP, and what is the related with the spatial unit? Modifiable areal unit problem arise from the fact that areal units are usually arbitrarily determined and modifiable in the sense that they can be aggregated to form units of different size or spatial arrangement. Thus, the MAUP has two related but distinctive components: scale problem or aggregation problem. This mentioned from Jelinski in 1996. For example, this is the real data from the survey of indicator like this. And then, after the process of aggregation and scaling, the data will be like this. We can see that there are some misinformation in there. The first dimension of pixel is egg, multiple egg, and then after aggregation and scaling, the dimension of pixel become 4 multiple 4. And there are some data conclude in 1 pixel. Okay, next. So what is the implication of this problem to indicator of social vulnerability? For example, this is the community of people. And then census officer come to them and the data will be recorded. And the next, aggregation, scaling, makes the data stored based on hierarchy of administrative units. And then processing the data of indicator of social vulnerability to be an index of social vulnerability. The result of social vulnerability index will be used to make a decision to social vulnerability reduction. And the last step is the implementation of decision to the real population. And then this is the problem. If aggregation and scaling determination of administrative unit hierarchy do not cause MAUP, then this will not cause problem in decision making related to social vulnerability. But MAUP is not a problem that can be reduced. This problem only can be identified based on this solution. The first, we can use multiple scale if the data based on administrative units. Multiple scale can be obtained based on hierarchy of administrative units. For example, top level is city or county, and the next district, and the last village. And hierarchy of administrative unit, every country is different. And if the data based on pixel unit, like from photo imagery or satellite imagery, multiple scale can be assigned based on hierarchy of pixel resolution or number of pixels per zone. For example, based on pixel resolution, 30 meter multiple 30 meter, 10 meter multiple 10 meters, 2.4 meter multiple 2.4 meters, 0.6 meter multiple 0.6 meters. The second, spatial autocorrelation also can be used to identify how much the spatial object close with the other spatial object. Based on statistic calculation, there are two familiar or commonly methods to calculate spatial autocorrelation. They are Morse I or JDC, based on Nelson and they were mentioned in 2017 and Zielinski and Wu in 1996. And what is the spatial autocorrelation definition? Spatial autocorrelation measures how much close objects are in comparison with other close objects. Next, this is the formula of Morse I models. From this formula, we can see that the Morse I model want to see the close of spatial object to other spatial object based on average value. This is average value. This is the spatial object will be value. And this is the weight matrix. 1 if location I and G, two different cell or point. 0 if region is not adjacent to itself. This is the simulation. For example, xi is the spatial object will be value and the other spatial object is close with xi as a spatial object. And the Morse I range from +1 meaning strong positive, 0 meaning a random pattern, and -1 indicating strong negative spatial autocorrelation. And this is the formula to Gersi model. From this formula, we can see that the Gersi model want to see the close of the spatial object to other spatial object based on different value of spatial object with other closest spatial object. This is the spatial object and this is the spatial object. In Morse I, spatial object with different width average of spatial objects. But in currency, spatial object with different with another spatial object close. Like this, the simulation, and the result 0 indicated perfect positive autocorrelation, 1 indicate no autocorrelation or random, positive 2 indicate perfect negative autocorrelation or disperse. Okay, let's move on to the case study example for this problem. The first is from Jelinski and Wu in 1996. The location of this example is from Canada. In specific location is boreal forest of north central Manitoba, Canada. And the object of the research from this topic is landscape ecology based on NDVI classification. Spatial unit use, pixel unit from the 3 Lancet TM scales. Scenario of aggregation, use number of pixels in one zone. The first is 1 multiple 1 pixel. Second is 3 multiple 3 pixels. Third, 5 multiple 5 pixels. And the result, we can see that in the number of pixel is minimum, the index of Moran ice, the variant is range of variant is big. You can see in the red circle like this, but in number of pixel is big. For example, 15 multiple 15 pixel, the number of index Moran will be minimized in second red circle. You can see the difference in 1 multiple 1 pixel until 15 multiple 15 pixel. And the second example from Nelson and Brewer in 2017. The location of this study in state on Pennsylvania. Object of research of this study is about median household income. This is the part 1 of socio-economic data. And spatial unit used in this study based on administrative unit from block group, tract, and the top level is county. Maybe tract is similar with district, block group equal or similar with village. And data overview, we can see this is from block group, and this is the tract, and the last from county. We can see that in block group area, data of median household income have some variance, you can see. But after the data enter in the next level, tract and county, the data not have some variance again, but tends to be clustered like this, cluster in high median income household and low median income household. In blood group, we can see the data variance is random, but in county level, the data variance is clustered. So the conclusion of this topic is social vulnerability reduction is one way to reduce disaster risk. Therefore, an AUP problem due to aggregation and scaling are kept to a minimum to influence to presentation of the social vulnerability indicator. Second, the greater of the MAUP influence the presentation of indicator of social vulnerability, it will also have an impact on disaster risk reduction effort. MAUP is a problem that has no solution. It can only be minimized by aggregation or scaling based on spatial autocorrelation like from to example in case study before. Okay, this is some reference that used in this article. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh. See you in the next presentation.